Hey guys, this is Ulrich from Nostalgic Mathematics. Today we want to solve this equation over the set of real numbers. If you are new here, do not forget to subscribe. We want to solve for x this equation. It is clear that x cannot be equal to 0 because if x equals 0, this quantity is going to be 1 minus 1 equals 0, and then this limit won't be finite. So this case is rolled out. Now we're going to use two well-known results to solve this problem, because we know that the limit of log 1 plus t over t equals 1 when t goes to 0, and the same one holds for this function a root e minus 1 over t. Now we call this quantity here f and x. So what I'm going to do next is that I'd like to get rid of this term. So to do so, we just have to multiply both numerator and denominator by n to negative x. And then we have this, because actually multiply by n to negative x is like we have to divide this term by n. So the remaining term will be here 1 minus 1 over n, and that's right. Next, we write these as an exponential. So this is going to be e to x multiplied by log of 1 minus 1 over n. That's right. Now, what we want to do, we'd like to have this pattern here, e to t minus 1 over t, where t is this exponent. So what we do next is that we had t here as a numerator. T is x multiplied by log of 1 minus 1 over n, and then we compensate here on this denominator. And this is still the same quantity, f and x. Now, we have this term. If we set here t is negative 1 over n, this is going to 0. So we may want to have again this other pattern. So to do this, we need to introduce a numerator negative 1 over n. But here we'll just introduce 1 over n as here. So we introduce 1 over n, but to compensate this, we just multiply something by n. And multiply this by n. At the end of the day, this is going to be as the exponent of n, because we just have 1 to 2021. So this is 2022 minus x. And here we push a minus 1, and this minus 1 will turn this into e to x log 1 minus 1 over n minus 1. So as you guessed, we know the limits of the first terms of this product because of these results. So this limit is going to be 1. Actually, just use these with t equals x log 1 minus 1 over n. Because when n goes to infinity, this is going to x log 1, which is 0, because log 1 is 0. So this is working. Now, here, we're going to have 1 as limit because we use t equals minus 1 over n. And this is going to 0 when n is going to infinity. Now, since the limits of both first two terms is 1, we know that the limit of f and x will be defined by this limit, but this can be computed easily by cases. Well, now this limit is going to be plus infinity if x is less or equal to 2022, because this exponent is going to be positive and this is going to infinity. But when x is greater than 2022, this is negative and the limit is going to 0. So actually it is 0 over x, which is still 0. But for x equals 2022, this is 0. So we have 1 over x, which is 1 over 22, because x is 2022. So at the end of the day, the limit of f and x is this limit, and it is the same outcome as here. Since we want this limit to be 1 over 2022, we see that the only solution is x equals 2022, and we are done. Thank you for your attention. Again, do not forget to subscribe, like, share, and post your comments. Bye.